Hey, what's up, guys? Welcome to the last and final video on this page for JSON Web Token attacks. We're gonna be going over JWT authentication bypass via. Let me stop this music. Via KID header path traversal. So let's get right into it. Let's read a little bit. I think there are two more labs here. Algorithm confusion. I'll do these two. These are two labs. They're rated expert, so they might take a little bit for me to get it done. Just so like I make sure. Oh, okay. Okay, they kind of teach us how to do it, so step by step. So that should be fine. We could go over that in the next video then. But this is the last lab found on this page specifically, and let's read a little bit about it. So, if the server, let's start up here. So it says, servers may use several cryptographic keys for signing different kinds of data, not just JWTs. For this reason, the header of a JWT may contain a key ID parameter, which helps the server identify which key to use when verifying the signature. Verification keys, KIDs, are often stored in the JWK set, like we saw above. In this case, the server may simply look for the JWK with the same KID as the token. Okay. However, the JWS specification doesn't define a concrete structure for this ID. It's just an arbitrary string of the developer's choosing. Okay. So in this parameter, it's also vulnerable to directory traversal, and an attacker can potentially force the server to use an arbitrary file from the system. Okay. So first, what we understand is that we can change the key ID to any static file or whatever that we can run. Like we can lead to on our system. This is dangerous if the server also supports JWT signing using a symmetric algorithm. So we're gonna probably have to sign the token with a symmetric key. In this case, an attacker can potentially point the KID parameter to a predictable static file, then sign the JWT using a secret that matches the contents of this file. Okay. So, last thing it says, you can theoretically do this with any file, but one of the simplest methods is to use dev-null, which it's present on most Linux system. Okay, so we're gonna have to point it to, we're gonna have to use path traversal, directory traversal to point to dev-null. And if this is an empty file, fetching it returns null. Okay, great. Therefore, signing the token with the base 64 encoded null byte will result in a valid signature. Okay, sounds good. So let's get on with the lab. We kind of have an idea. We have to sign it using a symmetric key, and then we also have to lead to dev-null through the KID, using path traversal or directory traversal. So let's log in as Wiener and Peter, and let's intercept this request, this post request. Now we're gonna change the get parameter to admin/admin because that's we want to access the admin portal, and I send this to repeater. You could delete this because we're gonna create a new one. So here we're gonna change the sub to administrator because that is the user we are trying to become. We have the KID parameter. We need to change this to dev-null. I remember in path traversal, if you go back 2 directories and you still don't lead up to this file, you can keep adding .. until you eventually lead into the file. So you just gotta kind of play around with it until you reach the intended location. So now let's go to JWK editor keys, and we're going to create a new symmetric key. Doesn't really matter what size. Okay, so the KID is good, everything, and now let's sign it using a base 64 encoded null byte. Oh, I should not have done that. Okay. So that should be good. Go back to repeater, and we're going to sign it. Let's not modify the header because we only need the KID and algorithm really. Okay, everything should be fine now. We have signed it, and we are leading to our /dev-null, and if we send it, we get an HTTP 200, and we are an admin. So let's try to remove one of these and send it. we are unauthorized. And then if we send it back with this, we are authorized. Okay, so yeah, you kind of have to play around with how many directories back you're going until you reach the intended file. So if we render it, we should be good. We should be back as admin. And let's request in browser. Let's copy this. Let's get rid of our proxy. Let's copy our new token, intercept this, and delete the user Carlos. Let's paste, forward, paste, and we have successfully solved the lab. So let me take this off and go back to our attacks. And if we go down, we can see that we did successfully sign it using a symmetric key. We have led to the dev null path. It just takes a little bit of playing around with. And then we are signing the token with a base 64 encoded null byte. So we are good. We have solved the lab. This is going over what we're going in the next video, so I won't touch it right now. And thank you guys for watching.